Hi, and welcome to the video on power rules. This video is designed to help you with multiplying polynomials, which is something that we'll be doing in the near future. All right, so let's begin. First of all, what are power rules? Power rules, as you probably know, are the rules that you use when dealing with exponents. Let's look at a couple of examples. So when I say dealing with exponents, I'm actually talking about dealing with them when you are performing some sort of math operation like addition, subtraction, multiplication, division, and even raising to a power. So typically when we're thinking about addition and subtraction, if we take something like 3p plus 4p where we have a variable there, and remember, if there's no number written in for the exponent, it's actually there, it's 1. And if, let's say p is representing the number of pigs, so 3 pigs plus 4 pigs, we know that's going to give us 7 pigs. But what does that look like mathematically? You've seen this before, where we can kind of break down the 3p as in 3 separate p's or 3 separate pigs being added together, and then add to that, again, 4 separate p's this time, all being added together. And if you counted the number of p's, you'd see that they were 7 p's. So noticing what's happening to our coefficients there, we're just adding them and we're keeping the exponent. The exponent remains a 1 in our final answer, so we get 7p. Now, with addition and subtraction, we do have to remember that like terms are important. If we have something like 3p plus 2h, where they're different variables, they do not combine. So if we have 3 pigs and 2 horses, when we combine them together, we really just get 3 pigs and 2 horses. And if we take something like 2s squared plus 2s cubed, where they are the same variable in this case, and let's say s squared is the area of a square and s cubed is the volume of a cube. If you were to add the area of 2 squares and the volume of 2 cubes together, you'd still get the area of 2 squares and the volume of 2 cubes. They can't really combine because they're not like terms. In this case, it's because the exponents are different, even though the variables are the same. For multiplying and dividing, well, remember in this case, when we break this down, just like we did up here with the addition example, when we break this down, we're breaking it down by factors. So we can break this 5x to the 4th down as 5 times x times x times x times x, and 6x to the 7 as 6 times x times x times x times x times x times x times x. And when we do that, our coefficients are just going to multiply as we expect them to. 5 times 6 will give us 30. And then now if we look at our x's, we have x times x times x and so on and so on. We have 11 x's being multiplied by itself, or x being multiplied by itself 11 times, which is the same as x to the 11th power. So our coefficients will multiply and our exponents in this case, 4 and 7, will add to give us 11. We can look at another example, this time with different variables. In this case, when we break it down, the same thing happens. We break it down into its factors. We would get, in the end, our coefficients multiply 5 times 6 to give us 30. And then for our x variable, since we have 11 x's again still being multiplied by themselves, it's x to the 11th. And we have 1y times 2 more y's, so that becomes y cubed. All right, all of that totally makes sense to us, but when we're dealing with power rules in an actual operation, we don't want to have to do this each and every time to try and figure out what we're supposed to do with exponents and coefficients. So it's your job now to memorize them. And what I'm going to do is I'm going to kind of summarize some rules, and there's still a trick that you may choose or you may not choose to use, totally up to you. And this trick is actually going to involve this diagram up at the top here. So this is where your notes begin, by the way. This diagram I like to call it an operations pyramid, where all of the operations that we typically use, addition, multiplication, powers, subtraction, division, and roots, are all outlined in this pyramid. Before we do that, let's go and describe coefficients. You all know how to find coefficients. Those are the big numbers in the front of the variable. And they do the operation that you expect them to do. So this is something you have to memorize. Coefficients do exactly what you say that they're going to do. And exponents, those are the small numbers in the back, and they do a lower operation according to this operations pyramid. So again, this is just a trick. There really isn't any principle behind this. If you arrange your operations in such a way where the most basic operation is to do nothing, right? So most basic math operation is just do nothing to it. And then the next most basic is addition and subtraction. Those are sort of the easy things. You learn them in elementary school. And then when you go up to another level, they get more complicated when you multiply and divide. And then finally, the most complicated, powers and roots. So as you see this pyramid, the way that it works, it increases in complexity as you go up. And the other thing to consider about this pyramid is that the left side of the pyramid has the operations that typically causes things to increase. So when you add things together, they typically increase. Multiplying, they typically increase. Powers, typically, you raise something to a power, it gets bigger. And then on the right side, those operations, when you perform them, typically causes numbers to get smaller. So when you're subtracting numbers, they get smaller. Dividing numbers will give you a smaller result usually. Same thing with taking the root of something like square root or a cube root. Usually get smaller numbers. So that's what the way this pyramid is divided. And this is kind of easy to remember, the way that the pyramid is, sort of arranged. And how can we use it? You don't have to use it. But here's what you do have to know. So if you look at our example here under addition, so let's get right into the meat of it here. Look at the addition example and take a look at what's happening to our coefficients and to the exponents. All right, as you notice, you can see that the coefficients 7 and 4 will add together to give us 11, and our exponents, they don't change in our answer, right? So how can we use this operation pyramid to help us memorize that? Well, as it says here, the coefficients are the big numbers. They're going to do what you say. So if we're adding, you just have to remember that. Coefficients do exactly what you say our coefficients are going to add. And the exponents, if we're using this pyramid, they do the lower operation. So below the addition, according to this pyramid, is nothing. So coefficients add, and exponents, they do nothing, which means they stay the same. We can look at the subtraction example and see the same thing happening as well. Coefficients here in this subtraction example, 7 and minus 4, which gives us 3. So since we're subtracting, we're expecting our coefficients to do that. They are going to subtract. And the exponents, on the other hand, well, again, they're the smaller number, they do one level below. And they're going to do nothing, which again means that they stay the same, we keep them. For cases where we are multiplying, so we're going down now here to the product of powers. Product is the answer or result of multiplication. Again, if we're multiplying, what are the coefficients going to do? Exactly what we say. 3 times 4 gives us 12. And the exponents, being that smaller number, is going to do one level below. So if you look under the multiplication in the pyramid here, they're going to add together. So our coefficients will multiply. If we're multiplying, they do it. And the exponents are going to do one level below that, which is addition. For division, similar thing happens. If we are dividing, then our coefficients are going to divide. So 20 divided by 5 will give us 4. And our exponents, they're going to do one below division, which according to the pyramid, right under division is subtraction. So they're going to subtract. 10 minus 3 gives us 7. What I want you to pay careful attention to here, though, is just as you notice 20 is being divided by 5, order in this case counts, 10 is going to be subtracted by 3, not the other way around. So you have to be very careful about that with these cases here. Finally, we have the power of power rules. So in this case, we have 3x to the 5th being squared. If we're squaring something, what are the coefficients going to do? You guessed it. They are also going to square because they do exactly what you say. And so they're going to be raised to the power that you say you're going to raise them to. The exponents, on the other hand, if you look under powers, they're going to do one level below, and one level below under powers is multiplying. So our two exponents, 5 and 2, 5 times 2 will give us the 10. Same thing with roots. If you're taking the root of something, the coefficient, you will take the root of it. So cube root of 125 is 5. Now for the exponent, under roots, it's division. And so if you divide 6 by the index of the root here, which is 3, 6 divided by 3 will give us 2. And so our answer here is 5x squared when we take the cube root of 125 times x to the 6th power. Just like with the division case, you have to be very careful about the order in which you do it. So it turns out it's the inside power that gets divided by the index, okay? So you just have to be careful. And if you ever want to check, you just do the inverse operation. So the inverse operation of a cube root is cubing. So if you want to check to make sure this is the right answer, take 5x squared and multiply by itself 3 times. 5x squared times 5x squared times 5x squared will give you 125 times x to the 6th. All right. I hope you guys have a quality weekend. Don't forget to do your Delta Math practice, and I'll see you all soon.